Hey everybody. So in this video I want to address some of the topics that we've been discussing, some of the things that you've brought up, and some of the ways that you've been approaching Max that I think you might want to adjust a little bit to help with your progress in the language. And the very first one of those is that you need to continually remind yourself that Max is a language and to think of it linguistically. Like a lot of you are asking for more examples of objects, and it doesn't help as much as you think it does. If you think about it linguistically, let's say you're trying to understand a word like you in English. Examples of this are not useful unless you fundamentally know what this word is. You are at the store. There's an example of you. I like you. The examples themselves only become useful when you understand that you is a pronoun and it stands for the person or group of people that you're referring to. Once you know that, the examples make sense, but the examples didn't actually help you understand the word. Once you have that basic concept of what this object, this word, does, the examples are illustrative, but they're not definitional. So let's apply that to a Max object, like one that's discussed often is cycle. More things you can do with cycle, more examples of how to use cycle, I think is barking up the wrong tree. What does cycle do? In the same way that what does the word you do? Once you grasp that, then you find that you can use it in all sorts of places very naturally because you fully grasp what it does. Like the majority of Max objects, what it does is completely simple and transparent. It is, as I say many times, the majority of Max is non-mysterious. Things go into objects, the objects do something to them, and things come out of objects. And we can see that, and often we can hear it, and we can always look at it numerically. So, what does cycle take in? Cycle takes in a frequency, how often it's going to cycle, how often it's going to oscillate in hertz or cycles per second. So let's do, say, cycle 0.1. That's going to cycle every 10 seconds, 0.1 hertz. And what comes out? A floating point number between -1 and 1. And every 10 seconds, because we've set the speed to 0.1 hertz, it's going to cycle between -1 and 1. And again, you don't need to even know this, because if you forget it, you can make what I just made here and see it and say, okay, well, that's not very graphical, so we'll stick a multi-slider there just to see it better. And now, okay, we get a pretty clear idea of what cycle's doing. Cycle's going from the bottom through 0 up to 1. Repeat, and that's all it does. Cycle makes this oscillating pattern from -1 to 1. And if we make it faster, make it twice as fast, we see the oscillation happens twice as fast. Make it twice as fast again. Now the oscillation's happening every 2.5 seconds, every 2 seconds, or every second. And again, you can discover all of this just by giving the object input and seeing what the object puts out. And if you want to visualize this even better, there's a couple attributes of multi-slider. There's a line scroll. We'll slow this cycle back down. that will show you the shape that it's generating. It's like, okay, here I have a thing that makes values go up and down. What can I do with values that go up and down? And the answer is anything you want to. Any time you need values that are oscillating, you can use a cycle. And of course there's other objects that produce other shapes as well. But cycle is kind of a fundamental shape. So what are things that oscillate back and forth? Well, one thing we know is that speaker cones oscillate back and forth. And if you oscillate them this slowly, we're not going to be able to hear them, because pushing a speaker cone back and forth over the course of 10 seconds isn't going to move the air in a way that's audible. But pushing a speaker cone back and forth 100 times a second is going to produce a tone that we can hear. And doing it 220 times per second is going to give us the pitch of A. So, okay, but that's only one thing that can be moved back and forth. Graphical objects can be moved back and forth, and notes on a piano keyboard move back and forth. That's a lot of what music is, actually, is this sort of back and forward motion. So, you could generate a pattern of notes from a cycle. Now, obviously, the cycle is oscillating between -1 and 1, and this keyboard is dealing with a much different range. From this keyboard showing us 36 to 83. And again, I didn't have to know that. I didn't have to read about it. All I had to do was hook up a number box and try it and see what it put out. Give it some input and see what response it makes. And also I can see what output it makes, which you probably are aware is just the same as the number that you put in. The case ladder is effectively a kind of number box. So if we wanted to get this range from -1 to 1 up to the range of 36 to 83, one way would be to use the scale object, scale -1 to 1 to 36 to 83. And now my cycle's playing the keyboard up and down. Right? Cycle is generating this pattern that goes up and down, so anything that we want to go up and down, we can do that with a cycle. It could be notes, it could be brightness, it could be saturation, it could be X position on the screen, it could be scale, it could be literally anything. It's just a number that's going up and down, and if there's something that we want to go up and down, cycle is an option. So you see, it's kind of backwards, I think, from the way a lot of you are thinking of it. Like what do I connect cycle to? What other objects does cycle work with? That's not a productive way to think about Max. What does cycle take in, and what does cycle put out? That is a more Max-like way of thinking about it. Cycle takes in a speed and puts out an oscillation between -1 and 1 at that speed, at the specified speed. And that's pretty much all it does. So what does this sound like? Well, we can use another cycle to hear it. These are MIDI note numbers, so we'd need an MTOF. I'm going to use an MTOF tilde because of where I'm taking this patch later. And the only difference between MTOF and M2F tilde is M2F tilde takes in a signal and puts out a signal. So I'm going to convert my integer to a signal here, pass it through the cycle, and I'll just borrow this structure to hear it. Okay, so that's a starting place for something. And then what I want to look at next is how max is very fundamentally, and this is something we haven't talked about, and I think it's an important point to make. Max is improvisational. There's no specific place to go from here. I mean, if you have a specific goal that you're trying to implement for a specific piece or a specific performance, maybe you do have a goal. But right now we're just learning the language. We're just studying the language. We just want to expand on this. And how can be guided by what's there. I mean, scale, again, is an object. Like all objects, it takes something in and it puts something out. What does it take in? It takes in a range from -1 to 1. And I just put the floating point here to indicate that the incoming values are floats. And then it puts out a range from 36 to 83. And then it's got inputs that allow you to change these arguments. Low input value, high input value, low output value, high output value. So what's the next step in this patch? Maybe try some different ranges. Or not. It's not that this is the right thing to do. This is a thing to do. So right now we're at 36 to 83. Right, I've narrowed the range, so it's narrowing the notes that it's running up and down on the keyboard. And I want to change this to a signed display. Just so it orbits around 0, it's a little bit easier to see. And again, thinking improvisationally, this is interesting. What else could we do? One of the things that's always handy to do if you've got something that's working is make another one. So what happens if this is being driven by 2 cycles? If we want to add these together after they've been converted from signal into float, we could add them like this. I think I would rather, and again, there isn't a right answer here, I think I would rather add them as signals so that I keep them in the signal domain. So let's and notice that unlike a normal number box, number tilde does not pass the value out its outlet. So you don't want to use the left. The left outlet has a different purpose in number tilde. It's a little bit counterintuitive. But don't try to pass your value through a number tilde because it won't work. So I'm creating some multiply tildes for gain, and then when you're in signal world, all you need to do to add 2 signals together is connect them to the same inlet. When you're dealing with floats or ints, you need the plus object. If it's floats, you need plus with a floating point value. But in signal land, just connect them to the same inlet and they're added together. So now we have 2 cycles. And I'll turn this one on and I'll turn this one off. So now we're just seeing the left cycle. In fact, I can use this number box to show the scaled output. like so. So right now this cycle is going at 1 time per second at full amplitude, and this cycle is going at 1 time per second, but it's turned off. 0 amplitude multiplied by 0. So this is going to be similar to what we just had. And as I add the second cycle in, the two waves will be added together, and you'll be able to see on the multi-sliders what each one is contributing. And one thing you can do here to visualize this better, and again, I'm always in Max improvising and also trying to see what's happening. You know, you see me insert a lot of unnecessary number boxes and buttons and multi-sliders and things into my patches. It's because I always want to see what the data is doing. I always want to see how things are flowing. It just helps me understand what's going on. So if I just pack these two floats together from here and here, and make another multi-slider. Multi-slider is just really one of those incredibly useful objects that you're just always putting in your patches, either as user interface objects or as we're doing here, display objects. So just put these in a line scroll mode and turn it back on, and we should be able to see how the two waveforms are interacting. We've got the quick oscillations on the right being added to the slower oscillations on the left. So it's giving us a pattern that on the large scale is moving up and down across the keyboard, and on the small scale is moving up and down around the note. We can slow this down even more to make that clearer. And again, if you're not relating to this musically, that's fine. You know, its cycle is not, you know, we just happen to be controlling a K-slider. What we've got fundamentally is an oscillating value, which if we make a jit.world, and a layer, drop an image in, scale it down, and use the cycle to move it around. This is -1 to 1, just like the output of the cycle. So all we need to do here is make a position attrui, Right. So, movement of an image on the screen, movement of notes on the keyboards, movement of a speaker cone, movement of anything is what we're manipulating here. And because everything just becomes numbers, something going from -1 to 1, we're just in a space where we can take those numbers and apply them to anything that we can imagine. Any aspect of sound or image can be modulated, is the term for it. We're modulating some aspect of sound or image.